In this video, I am going to continue our previous chapter 5, Exponential and Logarithmic Functions. In the previous video, I have discussed exponential function, exponent, and laws of exponent, graph of exponential function. In this video, I am going to discuss what is logarithm and laws of logarithm, graph of logarithm. And there are two special types of logarithm, which is common logarithm and natural logarithm. So the first question is, what is logarithm? Any number we can represent by exponential form like this, n equal a to the power x, where a is the base, and we know base should be always positive but not equal to 1. So any number, if you can write in exponential form like this, n equal a to the power x, then from here we can write x equal logarithm of n to the base a. So this is called logarithm. This x is called logarithm of this number n to the base b. This one we should read logarithm of n to the base a. We should not say logarithm of a base n, something like this. Instead, we should say log n to the base a. So let me say it again. If n equal a to the power x, where a is positive but not equal to 1, then the index x is called logarithm of n to the base a, and we write x equal log n to the base a. For example, you see 81 is a number which we can write in exponential form like 3 to the power 4. Then 4 is called logarithm of 81 to the base 3. Let me discuss some other example. 64 we can write in exponential form like this. 64 is equal 2 to the power 2 to the power 6. This is an exponential form of 64. Exponential form of forms of 64. Exponential forms of 64, number 1. There is another exponential form of 64. Let's say 2. 64 is equal 4 to the power 3. And another one, we can write 64 in another exponential form like 8 square. And the last one, we can write 64 is equal 64 to the power 1. So these are the exponential forms of 64. Now the corresponding logarithmic form of 64 will be what? Depending on base 2, 4, 8 and 64, we can write logarithm of 64 to the base 2 is equal 6. So this is the logarithmic form of 64. You see, this is the exponential form of 64, this one, and this one is the logarithmic form of 64. So from here you can decide, you can write this one, and conversely from this one you can write this one, because both are equivalent relationship. This relation and this relation, they are equivalent relation. But the form is inverse form, because exponential function and logarithmic function, they are inversely related to each other. So the inverse form of this one is this, but these forms are equivalent form. For the second one, the logarithmic form of 64, if base is 4, then the answer will be 3. And for the third one, logarithmic form of 64 or log of 64 to the base 8 will be equal to 2. And for the fourth one, the equivalent relationship will be 64. And what is base here? 64. Log 64 base 64 equal to 1. So from here we can easily understand the relationship between exponential form of 64 and logarithmic form of 64. Note that two forms are equivalent relations. They are equivalent relations. From here you can decide this one, and at the same time from logarithmic form you can decide the exponential form. For example, if p to the base q, for example, equal to x, then from here you can write p is equal q to the power x. This p will be in the left side, you see, and q base to the power right hand side, q to the power x will be in the right hand side. Or if you are given this one, let's say m equal b to the power x, and from here you can write log m to the base b equal to x. So you should have ability to move from here to here or from here to here. Two relations, they are inversely related to each other. And let me now discuss two special types of logarithm depending on their base. The first one is common logarithm. A logarithm having base 10 is called a common logarithm. For example, log x to the base 10, this is a common logarithm. Why? Since the base of this log is 10, and common logarithm of for example log of x to the base 10 we can simply denote by log x. When you write log x, it indicates that there is base 10. যখন লগারিদমের কোনো বেস উল্লেখ থাকবে না, এখানে ধরো কোনো বেস নাই, তাহলে তোমার ধরে নিতে হবে 10 আছে. If there is no base mentioned, then you should consider 10 as a base. For example, this one, 10 square equal 100. From here you can write logarithm of 100 to the base 10 equal to 2. And this one, log 100 base 10, we can write simply log 100. So in your calculator you can, there are two log. One is log, another is ln, logarithm and ln. Ln log is the common logarithm. In your calculator, when you see log, which indicates common logarithm, and when you see ln, this indicates natural logarithm. What is natural logarithm? The logarithm of a number to the base e, and e is a constant which is approximate value of e 2.72, but this is an irrational number like this. So a logarithm having base e is called a natural logarithm, and natural logarithm of x to the base e, this is a natural logarithm. This one we can simply write by ln x. So when you see in your calculator ln x, it indicates natural logarithm. Okay, you see y equal e to the power x, which implies x equal log y to the base e, and this one you can simply write ln y. So we understand definition of logarithm, common logarithm and natural logarithm. We also find a relationship between exponential form of a number and logarithmic form of a number. Now, what is a logarithmic function? a function in this form, log x, a function y is equal log x to the base b, where b is positive but not equal to 1. This is called logarithmic function, and here x will varies but b is fixed. For example, y equal log x to the base 2. This is a logarithmic function, y equal to x to the base 2, and corresponding exponential function is this, y equal 2 to the power x. So y equal to 2 to the power x is the exponential function, and corresponding logarithmic function is this. Okay, here it should be x equal to 2 to the power y, x equal 2 to the power y. Okay, x equal 2 to the power y is this relation, and this relation, they are equivalent relation. However, y equal 2 to the power x is an exponential function having base 2, and y equal log x is a logarithmic function having base 2. Now you will easily understand why two functions are inversely related to each other if you look into the graph of those functions that I will discuss later. But before that, let me discuss exponential rules. But before that, let me discuss rules or laws or properties of logarithms. And for a, when a is a base, we can write log x times y is equal log x plus log y. You see, left hand side, this log is of base a, and this one also base a. The base should be same. For example, let's say log 5 into 8 to the base 3, this equal, I can write log 5 base 3 plus log 8 base 3. Base should be same. And again, when it is in division form, log 5 by 8, for example, having base 3, then it will be log 5 base 3 minus log 8 to the base 3. This is formula 2. তাহলে কি দেখলাম, গুণের ক্ষেত্রে প্লাস হবে আর ভাগের ক্ষেত্রে মাইনাস হবে. Now the third one is called power rule, x to the power y. This power will you can put as a coefficient. For example, log x square base, let's say 5, is equal to log x to the base 5. So this power you can write as a coefficient. This is called power rule. And fourth one, log 1 will be always equal to 0, whatever the base is, log 1 equal to 0, and log a to the base a. For example, we see before log 64 base 64 equal to 1. So when the number and base same, then the answer will be 1. And formula 6 is called change base formula. By using this formula, you can change the base of a logarithm. For example, let's say you have a logarithm having base 3. This is a logarithm having base 3. Now you need a logarithm having base 5. So you can now write this one as a fraction of two logarithms, log 2 log 3. This 2 means this 2, and this 3 is this 3. Now if you need a logarithm having base 5, you can put 5 here and here. Note that these two logarithms in this fraction will be of same base. If you need a logarithm having base 7, then you should put 7 here as well as here. So this is called change base formula. You see log x to the base b, log a to the base b. In the left side, this log is of base a, but in the right side there are two logarithms having base b. So by using this formula, we can change the base of a logarithm. Now let me discuss the graph of exponential and logarithmic function. In my previous class, I discussed this graph y equal to 2 to the power x point by point. Now I want to discuss y equal to log x to the base 2 point by point. So you see when x equal 0, when x equal to 1, y will be 0. So this point, this is a point having coordinate 1 0, because we know log 1 equal to 0. From this relation we know log 1 equal to 0. So this is a point. And second point, I want to consider 2. When x equal to 2, y will be log 2 to the base 2, which is 1. And this is nothing but this point, 2 1. And the third point, I want to consider 4. When x equal to 4, y will be log 4 to the base 2, and which is equal log 2 square base 2, which is equal to log 2 to the base 2 equal to 2. So when x equal to 4, y will be 2, this point, and so on. And what happened when, for the lower value of 1, when x is lower than 1, below 1, then what happened? For example, when x equal to half, then it will be log 2, half means 2 to the power negative 1, which is negative 1. So when x equal to half, y will be negative 1, this point. And when x equal to 1 by 4, y will be negative log 2 negative 4, 1 by 4, which is 2 to the power minus 2. So the answer is minus 2, and which is this point, and so on. So this curve form an asymptotic behavior in this area with the y-axis, and when x increases, y increases. Note that log 0 is undefined or indeterminate. However, log 0 plus means it's a very small number which is a bit bigger than 0, and that will be negative infinity, because when you consider 0 plus, the curve will meet to the y-axis at negative infinity. So this blue line is the graph of y equal to log x to the base 2, and this red line is the graph of y equal to the power x. So if you put a mirror with this line on this line, y equal to x, then from this side, if you look into the mirror, you will see the exponential graph, and from this side you will see the logarithmic graph. It means exponential function and logarithmic function graph of exponential function and logarithmic function, they are symmetric to the line y equal to x. And if you look at here, this is, we know y equal to 2 to the power x is an exponential function, and corresponding inverse function, if you just interchange x and y, you will get corresponding inverse function. Instead of y, if you put x, and instead of x you are putting y, and this is nothing but y equal log x to the base 2. So this is a logarithmic graph. So from these graphs we can decide that logarithmic function and exponential function, they are inversely related to each other. You can look into another graph, b to the power x, b is positive, and here b is positive but not equal to 1. Okay, the corresponding logarithmic graph will be this one, and the domain of this function, exponential function, will be what? The domain of this function will be, domain means set of all values of independent variable x. So you are allowed to put any real value for this function in for x. So the domain of this function will be negative infinity to infinity, and the corresponding y values will be 0 to infinity. This is the range of exponential curve, and the domain of this curve will be what? You see the x, you are allowed to consider x only from 0 to infinity. 0 to infinity. This is of course open interval, because 0 is not included with the domain of this function. So, and the range of y will be negative infinity to infinity. So the range of logarithmic function will be negative infinity to infinity. Now you see, the domain of exponential function is equal to the range of logarithmic function, and range of exponential function is equal domain of logarithmic function. Therefore they are inverse function. You can also look in this graph. Before we sketch only this one, y equal to log x to the base 2, which is this. But if you increase base to e, 4 and 10, then the graph will be less stiff in this case. The second one, this one is a logarithmic graph function having base e, and this one is a logarithmic function having base 4. This one is a logarithmic function having base 10. So you can also consider these types of scenario when you are sketching a logarithmic function. That's all in this video, and in my previous video I discussed exponential function. In this video I discussed logarithmic function. In the next one I will discuss several problems related to exponential and logarithmic function. Hope you will not miss the next video. Thank you very much for your watching.